Hello viewers, I am Asim Ranjan Patnaik welcoming all of you to my channel Colorful World of Chemistry. Today we are here to discuss about the methods of preparation of our phenol. So we have to discuss by which methods or by what methods we can prepare our phenol. So the first method of preparation of phenol is the preparation of phenol from cumene, that is from cumene hydroperoxide. And this reaction is also known as the cumene hydroperoxide rearrangement reaction. So first of all we have to discuss what is cumene, how cumene is prepared, how cumene hydroperoxide is prepared, and how phenol is prepared from them. So we have to proceed through various steps. So first of all we have to discuss what is cumene and how it is prepared. So firstly, we have to prepare our cumene. So what is cumene? The other name of cumene is isopropyl benzene. So there is two parts, that is the isopropyl part and the benzene part. So how to prepare this cumene? From that is, now we know that there is two parts, that is one benzene part and another part is isopropyl part. So when benzene, the queen of chemical, our most loved and most charming benzene, when treated with propene and undergoes Friedel-Crafts reaction in presence of acids like phosphoric acid and sulfuric acid, we can get our cumene. So the reaction is just like this. When our most loved benzene, this is our benzene, and when it is treated with propene, this is our propene, and it undergoes Friedel-Crafts reaction. In presence of acids, just like our phosphoric acid and or our sulfuric acids, then it will give us our cumene. So what is the structure of cumene? Our cumene is just like this. This is our cumene. So now we have prepared our cumene. Then the next step is the formation of cumene hydroperoxide. No, but firstly we have to go for the mechanism how our cumene is produced from our benzene and from our propene. So we have to move for the mechanism how our cumene is produced or formed from our benzene and our propene. It is the theoretical concept or it is the general reaction, but we have to move for our mechanism, because in chemistry everything happens with certain evidence and in certain mechanism that we don't see, but we have to follow that. So what is the mechanism of that? As we know that there is the presence of our sulfuric acid and phosphoric acid. So any one of them we can take, that is we have to take that I am now taking sulfuric acid. It will dissociate, as it is one strong electrolyte, it will dissociate completely and it will give us one H plus ion, that is our proton, and HSO4 minus ion. So then what happens? As we have taken our propene, with propene, as there is the presence of unsaturation, there is the presence of what? Double bond. So there is some kind of electronegativity and there is a tendency for the arisement of negative charge over either of the double bonded carbons. So what happens? We have to see. It is our propene and here is the double bonded carbons. So as there is the presence of one proton, then there is also the tendency of either of the two carbons to abstract that proton. So what happens? Like this, the abstraction of proton happens. So what happens after this? our product will be this line. In this case, the proton is abstracted by this carbon, and here one plus charge got arised. So what happens now? What is this? It is one intermediate. What kind of intermediate? It is one carbocation, short-lived species, which can act as our intermediate. So it is our carbocation. So what is our another substrate? That is our benzene. How? Then nextly we have to move how our carbocation will react, or how the interaction between our carbocation and benzene will occur. We have to move for that. Now what happened? Now our benzene will react with this carbocation, our isopropyl carbocation. So what happens? As there is the presence of pi electron cloud around our benzene ring, so and there is the presence of carbocation. So what happens? This pi electron cloud will attract this carbocation towards itself. So what happens? This double bond will attack or attract this carbocation towards itself. So what will happen? This will be formed. This isopropyl carbocation part will be attached to this position, forming this. And there will be the arrangement of positive charge over this carbon atom. Why? As that there is a presence of double bond, and the double bond is shifted towards one carbon, which attracted this carbocation. So it get a positive charge. So now what happened? As we know, there is the presence of one hydrogen atom. So in this reaction, or in this step, the benzene or our aromatic compound has lost its aromaticity, and without its aromaticity it is not stable. So there will be the next step in which it will lose one proton and it will regain its aromaticity. So what will happen? Now see, in this reaction or in this step, the proton will be donated or furnished, and this bond will be shifted towards this, forming the double bond, and by this process our benzene will regain its aromaticity. And what's about this proton? Where it will go? It will go to the HSO4 minus ion, previously or primarily to which we produced. So this proton will be abstracted by that HSO4 minus ion, and it will give us our sulfuric acid again. So what will happen? So now our cumene or our isopropyl benzene is formed. And what is the side product? As we have taken H2SO4, that is the sulfuric acid, as one catalyst, so it will be regenerated again. So what will happen? This proton will be abstracted by that HSO4 minus ion which we have produced previously. So it will take that proton and it will form our sulfuric acid. And this is our most awaited cumene. So now we have prepared our cumene. That is the first step of our reaction, and now from it we have to proceed what? Again, to get our phenol through the formation of cumene hydroperoxide. Now we have to proceed for the formation of cumene hydroperoxide from the previously prepared or previously formed cumene. So how to prepare cumene hydroperoxide from cumene? So it is a process of preparation of cumene hydroperoxide, which is a type of free radical process, and it is one type of auto-oxidation reaction. So what do you mean by auto-oxidation? Auto-oxidation means one substance will undergo oxidation without any external reagent. That auto-oxidation is a kind of or certain kind of oxidation reaction that one will undergo spontaneously. So it is a kind of spontaneous oxidation. So it is known as auto-oxidation. So how? For this the presence of one free radical is mostly needed. So how we can proceed, how we can form our cumene hydroperoxide from cumene, we have to see. So here is our cumene, that is our C6H5 phenyl, and it is attached with CH, branched CH3 and branched CH3. Here is our what? Cumene. Here is our cumene. So as we have previously said that there is the presence of one free radical, that is one initiator which will initiate our process or preparation of cumene hydroperoxide from cumene. So this is like this is one free radical, alkyl free radical. So it will what happen, as there is a bond between our carbon and hydrogen, we have to show off that, and we know that a bond is formed and a bond consists of two electrons. So here is the electron and this is a covalent bond between our carbon and hydrogen. So they mutually share their electrons for forming a bond. So as this is one free radical, so this free radical will abstract, and free radicals are generated by homolysis. When there is no or very minute amount of electronegativity difference between two atoms, they will undergo homolysis and they will form free radicals. So what will happen, as this free radical is very free, so it will abstract this hydrogen to make a company for it. So what happens, it will abstract this and we will get one free radical which is our isopropyl free radical. So it is just like this, our phenyl group, then our carbon, then two CH3 groups attached to it, and here is one unpaired electron, which is now it is one free radical. So it is one free radical, and free radical we have to note, or we have to notice here that free radical is certain kind of reaction intermediate, and it is one intermediate which will help us to proceed our reaction in forward direction. So again, what will happen, how the cumene hydroperoxide will be formed? When our cumene is exposed to air, as we have previously discussed that it is a kind of auto-oxidation reaction and the substrate will undergo oxidation reaction spontaneously. So as we have generated one reaction intermediate, so it will interact with the oxygen atoms or O2 molecule present in the air to form our what? To form our cumene hydroperoxide after some treatment with other substrates. So we have to proceed for that. What will happen? As we have generated our free radical, that is C6H5 bond C, bond CH3, bond CH3, and here is the unpaired electron, and here is our free radical. So what will happen, as there is the bond, double bond between our oxygen atoms for the formation of O2 molecule, and as there is no electronegativity difference between our oxygen atoms, they will undergo homolysis forming two dots, that is the bond pair of electron will move towards each of the atoms. So now what will form, as there is one free radical, there is one free radical, and they both are free, so they will have a tendency for combination, so they will combine just like this. So what will happen, we will get our product like this. As we know that a bond consists of two electrons, here two electrons get combined and they will form a bond oxygen and bond oxygen with a free radical. So now we have to move for cumene hydroperoxide, and when we are very nearer, and now we are very near to our cumene hydroperoxide, so from this substrate, or by taking this as our substrate, how we can proceed for the formation of cumene hydroperoxide? We have to take another molecule of this substance, or we have to take another molecule of cumene. So what will happen? here is our free radical that we have formed in our previous step, and here is another what? Another molecule of what? Cumene. And like this, as it is free, it will abstract, or as it is free, it is lonely. It has a tendency to combine with somebody. So it will form a combination with this hydrogen, and it will form our most awaited what? Cumene hydroperoxide. So here is our cumene hydroperoxide. I have to write the name. This is our cumene hydroperoxide. Now we formed our cumene hydroperoxide. So now we have to proceed for the last step. How we can prepare phenol from our cumene hydroperoxide? That we have previously discussed that it is a method of preparation of phenol from which cumene. Firstly, we have prepared cumene, then we have proceeded for the formation of cumene hydroperoxide from cumene, and now we have to proceed for the formation of phenol from our cumene hydroperoxide. As previously we have produced our cumene hydroperoxide, now we have to move for the formation of phenol from that. So what kind of steps we will take for the formation of phenol from cumene hydroperoxide? So first of all, we have to know that the preparation or the method of preparation of phenol from cumene or cumene hydroperoxide, it is one acid catalyzed reaction or rearrangement reaction. So one acid will catalyze this. First of all, for the formation of cumene, we have taken our sulfuric acid or phosphoric acid. So as it is one acid catalyzed rearrangement reaction, so there is the presence of one proton. According to Bronsted-Lowry concept, acid is one substance which can donate one proton. So as it is one acid catalyzed rearrangement reaction, so there will be the presence of one proton, and as we have written or we have produced our cumene hydroperoxide just like this. It is our cumene hydroperoxide, and as it is one acid catalyzed rearrangement reaction, there is the presence of one proton in the solution or in the system. So as we know that the electronegative atoms has a tendency to attract some positive charge, as they have lone pair of electron, or they have maybe in some case they have negative charge over them. So as there is the presence of two oxygen atoms, there is the presence of also lone pair. So this lone pair will attract or will try to abstract that proton. So what will happen? The abstraction of proton will be happened. So what will happen? It will be formed just like this. What? And as this oxygen got one positive charge species, that is one proton, so there will be the arrangement of one positive charge over this electronegative oxygen atom. But we know that the positive charge over one electronegative atom is not stable. So what we have to do? We have to neutralize. We have to neutralize that positive charge over the electronegative oxygen atom. So what will happen? So again in the further step, what will happen? This bond pair of electron will move towards the positive charge and will neutralize the positive charge over the oxygen atom. So as the bond pair of electron, both of the electrons, bond pair electrons got moved towards the positive charge bearing oxygen atom for the neutralization of that oxygen atom, positive charge bearing oxygen atom. So what will arise? As these bond pair of electron have gone to that oxygen atom, so there will be an arisement of positive charge over this oxygen atom. So what will be our next product? So there will be an arisement of positive charge over this oxygen atom. And what is this? it is one oxycation. We have to name this as oxycation. And now also there is the presence of positive charge over oxygen atom. As we have previously produced our oxycation, and we know that the positive charge over electronegative atom is quite unstable. So now what we have to do? And as there is the arisement of positive charge, and according to the concept of nucleophile and electrophile, we know that it will behave as one nucleophilic center. But what will happen as there is no presence, or as there is the absence of one nucleophile in the solution? Then how it will be neutralized and how it will be attacked? So what will happen here? In this, the positive charge over the oxygen atom can be neutralized, or it will be neutralized by the preferential migration of this phenyl group towards this positive charge bearing oxygen atom. Then it will be neutralized. What will happen? And this shift of this phenyl group towards the positive charge bearing oxygen atom will leave one carbocation. What will happen? We have to see here. After the migration of this phenyl group with its bond pair of electron, which will neutralize this positive charge bearing oxygen atom, will also form one carbocation like this. There will be one question: why the phenyl group migrated preferentially but not the methyl groups? Why? We have to neutralize this positive charge. What do you mean by positive charge? Positive charge refers to the absence of electrons. So how? By giving electrons to that species, we can neutralize that. So in comparison to methyl groups, the phenyl group can donate enormous amount of electron to neutralize that positive charge over the electronegative oxygen atom. As the phenyl group, as the benzene ring, it is the part of our benzene ring, and as the benzene ring has a huge pi electron cloud, so it can sufficiently give the electrons to neutralize this positive charge over the electronegative oxygen atom. So in comparison to the methyl group, the phenyl group will migrate preferentially, leaving one positive charge over the carbon atom, forming one carbocation. Here is our carbocation. And carbocation, we know that it is one reaction intermediate. So as it is reactive and short-lived. So what will happen? We have to proceed. What will happen to this carbocation? And what will be formed as the product of this? As there is the presence of water, and there is the presence of also the lone pair of electron over the oxygen atom, and there is the absence of electron over the carbon atom, now which is bearing the positive charge over it. So what will happen? This electron will fill the deficiency of electron over the carbon atom, forming what? Forming this. So now this will be formed. What? This oxygen will be attached to this carbon, hydrogen are like this, and as it has donated its lone pair of electron to this positive charge bearing carbon, that is the carbocation. So now as he has also given his property to somebody, so he has this scarcity now, so there will be one positive charge over this oxygen atom, and again as we know that positive charge over the electronegative oxygen atom is quite unstable. So for gaining stability, one H plus will be removed from this, and the bond will neutralize this positive charge over the oxygen atom. So our next product will be and in the next step, the proton that was abstracted by someone, after this the bond pair of electron moved towards the positive charge bearing oxygen atom to neutralize the positive charge. So who abstracted this proton? This oxygen atom has abstracted this proton. So what will be formed here? Here this oxygen will acquire the proton or abstract this proton, and there will be an arisement of positive charge over this oxygen atom as he abstracted one positive charge bearing species. So now what will, as again this is one unstable condition, so how to stabilize this? Then we have to stabilize this thing. How? We have to neutralize this positive charge. I have to draw this again for clarity. I will again draw this species. And for neutralization of this positive charge over electronegative oxygen atom, some bond should be broken, and it should neutralize this positive charge over the oxygen atom. Then how it will be formed? How we can form this thing? So this will be, as this can neutralize, this bond pair of electron can neutralize the positive charge over this oxygen atom. The product will be like this. And here is our phenol. Now we got our phenol. But what about this? As the low bond pair of electron got removed from this carbon atom, so now he is electron deficient. So there is the arisement of positive charge over this carbon, forming one carbocation. So what will happen? This proton will be abstracted, and this bond will be shifted towards this, forming acetone and neutralization, which will contribute towards the neutralization of this reaction intermediate, that is our what? Carbocation. So it will be like C double bond O bond CH3 bond CH3. So what is our final product? That we assumed our phenol, for which we got this preparation. Now finally our phenol got prepared, and with phenol this acetone got prepared, and acetone is quite useful. It is one commercial substance of a wide use. So the reaction is quite helpful or fruitful for the formation of phenol as well as acetone. So thank you for watching my video.